Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we are going to talk about Pythagorean triples. Now I know I've already mentioned them to you, and we've been working a lot with them in homeworks, especially in quizzes. I've been showing you where to recognize them. But today we're really going to finalize these Pythagorean triples, and I'm also going to show you how to work with what's called families of right triangles, because it goes a little bit beyond just the Pythagorean triples. Now, Pythagorean triples are values and their multiples. Be very clear with that. And their multiples, which exactly fit the Pythagorean theorem or formula. Okay? These triples have been proven already. All of these will always equal a right triangle. Not sometimes, but always 100% of the time. Now, being that these values have multiples, there are literally an infinite number of possible Pythagorean triples. Infinite. It will never end. I do not expect you to memorize not even half of these. I am begging you, though, to memorize these four and then this last fifth one. You want to memorize more? Awesome. Like, no sarcasm. More power to you. That's awesome. However, these five are going to be constantly used, not only in this class, but in the SAT and the ACT and throughout your mathematical careers. And those include the 3, 4, 5 triangle and their multiples, the 5, 12, 13 triangle and their multiples, the 7, 24, 25 and their multiples, the 8, 15, 17 and their multiples, and the 9, 40, 41 and their multiples. Now, you may say, oh, I can't memorize all five. Memorize at least some of them. Any that you can memorize is going to aid you later on. The absolute most popular ones, though, for sure, are the 3, 4, 5 and the 5, 12, 13 and the 7, 24, 25. Those are the ones that I have seen most often, but I have also seen the last two, which is the 8, 15, 17 and the 9, 40, 41. Being that I want you to memorize those, that's why I gave you all five of these right here for you so you can see how they work. The 3, 4, 5, the 5, 12, 13, the 8, 15, 17, the 7, 24, 25, and the 9, 40, 41. Pretty self-explanatory. The larger side is always the hypotenuse. We know that, not only because it's the largest side, but it's always across the 90. Okay? So those are the Pythagorean triples that I strongly suggest that you memorize. Now, how the multiples work. I need you guys to understand that the multiples only work when every single value of the original Pythagorean triple is multiplied by the same value. You can multiply it by a decimal or by a whole number or by a radical. It does not matter. As long as every single value of the original Pythagorean triple is multiplied by the same real number, you're going to have a related Pythagorean triple. So the 3, 4, 5, if I multiply each of those values by 2, I've got a 6, 8, 10. If I multiply the 3, 4, 5 by each number by 10, I've got a 30, 40, 50. So how does that really help me, Mr. Moore? I don't get it. Okay, let's say you have a triangle like this. And I've got a 15 and I've got a 39. What's a common factor to both 15 and 39? 3. If I divide 15 by 3, what do I get? If I divide 39 by 3, what do I get? So what kind of a Pythagorean triple is this? A 5, 12, 13, but times 3. So this would be a 12 times 3, and that would be a 36. That's how this works. Yes, sir. Was there a case where it could be multiplied by 1/2? Yes, sir. That's very awesome. Let's say that I gave you 2.5 and 6.5. Okay? In this case, I would say, wait a second. What happens if I double 2.5? 5. What if I double 6.5? Gives me 13. So if I take 12, that's the doubled value, correct? So what would 12 divided by 2 be? It'd be 6. So yes, you could multiply by a decimal, a radical, a whole number, any positive real number, and you're going to have your Pythagorean triple. That was a brilliant question, by the way. Thank you. Does that make sense, gentlemen? Yeah? Okay. Now, excuse me. I'm going to find the value of x. Now, you may be looking at this and you may say to yourself, that's not a Pythagorean triple, Mr. Morrow. Well, yes, it is. You just got to use a little bit of ingenuity here, okay? This kind of relates to what my boy just finished asking. What happens here, guys, if I multiply 4 by 2? Okay, if I multiply 4 by 2, I get an 8. What happens if I multiply 7.5 by 2? I get a 15. And then this x I would also have to multiply by 2, correct? Okay, well, do you recognize what triangle this would be? This would be an 8, 15, 17 triangle, correct? Do you guys see that? No? My brother shook his head. Talk to me, Bob. I'm here for you. This is why I teach. You guys see, here's my Pythagorean triple, right, my man? That's why it's important to see this. And I'm going to show you a different way just in case you don't see it, okay? So I promise you don't stress. Yes, sir, my brother. Okay. Okay. Fantastic question. Let me first show you how to figure out solving for this x, and then I'll answer your question, then I'll go back to what if you don't even see it. So we know that if 4 times 2 is 8, 7.5 times 2 is 15. So that means 2x here has to equal 17, correct? But I'm looking for x, so divided by 2, so x will equal 8.5. So we're going to get into what you guys had asked, I promise. But do you see what I did there? Yeah? Okay. Now the question, which are very awesome and valid questions. The question was, how did you know to multiply by 2 as opposed to like 3 or 5 or 9 or 10? I'm no sarcasm here because I know my Pythagorean triples. I know that I said, wait a second, 4. So I'm going to go through all of them in my head. I know it's not a 3, 4, 5. I know it's not going to be a 9, 40, 41, right? But I did say, wait a second, 8. It could be an 8, 15, 17. And then I just did the math in my head. 4 times 2 is 8. Oh, 7.5 times 2 is 15. Oh, yeah, there we go. It's an 8, 15, 17. Now, this isn't easy to memorize. So what happens in a situation, you may be asking, okay, that's great for you, Mr. Morrow. Congratulations, we're real proud of you. But what if I don't see that on a test? Can we just use the Pythagorean theorem straight up? Is there any shame in that? Am I going to mark it wrong because you used the correct formula? Heck no. So this would be 4 squared plus 7.5 squared equals x squared. 16 plus, what is it, my man? 56.25. Thank you very much, sir. Equals x squared. And, now, are you sure about that? Yes, you are. And then plus 16. That's going to equal 72.25. Square root that. And you will get 8.5 equals x. So there's no shame. There's nothing to be embarrassed about. No worries at all. So why are you teaching us the other way if there's no shame here, Mr. Morrow? Speed, accuracy, quickness. It's a lot easier for me to multiply 4 by 2, that by 2, realize I got to multiply this by 2, and realize that 2x has to equal 17. It's just a lot quicker. It's just a lot easier. Does everyone see that? I'm not going to ever tell you guys that it's, super simple, but it's a lot easier, right? Okay, now, in this particular case, I've got 55, 77, and an x. Now, real quick, going through my limited knowledge of the Pythagorean triples, because like I said, I've memorized those 5. Those are the ones those are my go-tos. These don't fit any of these at all. However, sometimes we don't want to work with big, large numbers like this. So what can I do here? Yes, sir. You could divide each of these by 11. Very good. So this could really become a 5, 7 triangle if I divide everything by 11, correct? And then I can make my x here. And what would I have to do to this x, though, to get the final answer at the end? I'd have to multiply it by 11, right? So instead of having x over 11, let's just go ahead and do 7 squared, which is 49. 49, not 42, equals 25 plus x squared. So when I subtract 25 to both sides, I'm going to get 24 equals x squared. Square root both sides. That's 4 times 6. So x will equal 2 times the square root of 6. But what do I have to do? I've got to multiply that by 11, correct? So that would become 22 square root of 6. Now, some of you may say, but Mr. Morrow, I can just go ahead and use the Pythagorean formula and just use a calculator. Yes, you can. No worries. These are just extra skills that I'm giving you. Believe it or not, I'll challenge you any day of the week, and I'll do it quicker by hand than you guys by calculator. Not because I'm so awesome, it's quicker this way. So if you can find any little tricks like this, any little factors that you can pull out to make your life easier, I suggest it strongly. But that is totally up to you guys. There's nothing wrong with using these numbers in the Pythagorean formula. Yes, sir, my brother. Of course you can, my brother. Very good. My boy says, divide that by 2, which could give you a 5. Divide that by 2, which could give you, divide that by 2, which could give you a 12. And then this would be a 13. But what would I have to do to that? Very good. Multiply by 2, and that's a 26. So what he found out here is he said, wait a second. This is basically a 5, 12, 13 times 2. Yes, sir, my brother.
5, 12, 13. Like you get that, you assume it's 13.
No, you don't assume. You know, if this is a 5 and this is a 12, this has to be a 13. But this 5 was multiplied by 2. This 12 was multiplied by 2. So this 13 must be multiplied by 2. So I have a 26. No assumptions here. But thank you so much. Good question. Yes, sir, my brother. Of course you can. Does this make sense, though, guys? Do you see what's going on here? If you don't, just raise your hand, y'all. Again, Mr. Morrow, but I'm having trouble seeing it. I don't see what you're seeing, Mr. Morrow. So do it the long way. No big deal. There's no shame. Sir, my brother. I got a volunteer for the next one, but you could do the one after. Okay, here we go. We got a 9, 12, and an X. What common factor do you see there, brother? That's exactly right. If you divide this by 3, that's a 3. You divide that by 3, that's a 4. So this is a 3, 4, 5 triangle times. So this would be a 5 times 3, which would equal 15. 2 seconds. If you can recognize it. One trick that I always use, I try to see if there's a common factor. in the numbers that I see there. Right off the bat, I saw a 9 and a 12. I said, I could take 3 out of both of those. And oh, wow, look what happens. When I took 3 out of both of those, I had a 3 and a 4. Those are my legs. So my hypotenuse has to be 5. It's just a Pythagorean triple times 3. You feel me there, guys? May I continue? Okay, this is a good one. What would this be, boys? Someone gave me the answer. It's a 5, right? Good. I thought I was going to trick you there. This is not a 3, 4, 5. This is impossible to be a 3, 4, 5 because the hypotenuse has to be the largest one. So in this case, you're out of luck, Chuck. You're going to have to use the Pythagorean theorem. 4 squared equals 3 squared plus x squared. 16 equals 9 plus x squared. 7 equals x squared. X equals square root of 7. There's no other option here for you. Unfortunately. Unfortunately. Does that make sense, guys? You with me here? Now, but wait a second. Now that I'm thinking. Give me 1 second here. All right. All right, guys. Sorry about that. Okay. Yes, sir. No, why would it be x equals 7? No. No, it's okay, buddy. Thank you for your honesty, bro. Thank you. Okay, how about here? Find the value of x. What do you think? Could I pull this out? I don't know. Is that a 3, 4, 5? It's not a matter of thinking. Does 4 go into 18 at all here? No, I don't think so. So you could do this one of 2 ways, guys. You can use these values, which I'm totally cool with, or you can make your life a little easier. Can I take a 6 out of both of these and make a 1 and a 3 square root of 3 here? Because I took out a 6, correct? So 1 squared plus 3 square root of 3 squared will equal your x squared. That's 1. 3 times 3 is 9 times 3 is 27. So x squared equals 28, which is 4 times 7 when I square root it. So x equals 2 square root of 7. But what did I do? I had taken out a 6, right? So this is 2 square root of 7 times 6, which equals 12 square root of 7. Couldn't I have done that with the numbers they gave me, Moro? Yes, you could have. But in my opinion, it's easier to work with 1 and 3 square root of 3 than 6 and 18 square root of 3. Yes, sir, and then yes, sir. I'm sorry, my brother? I'm so sorry. A 6 is the same thing as square root of 36. Yeah, I don't see how that would help you here, though. Nah, I'm a little lost. I'm sorry. Okay, thank you, though, bro. We can talk about it after class, though. Yes, sir. Yeah, I did divide everything by 6 here. So if I divided, okay, what do I have to do to 1 to get to 6? I have to multiply by 6. What do I do to 3 square root of 3 to get to 18 square root of 3? I multiply by 6. So if I found that this was my 2 square root of 7, what do I have to do to that as well? Multiply by 6 to give me 12 square root of 7. And again, guys, for now, you're probably going to say, oh, this is too much. I'm just going to do it the long way. There's nothing wrong with that. Not a darn thing wrong with that. Where I would really try to focus on, though, me personally, more important than finding a factor and then doing the Pythagorean theorem anyways, is recognizing your Pythagorean triples and those multiples, because that makes your life just, boom, that much easier. That's what I would suggest strongly. Does that make sense, gentlemen? All right, I think we're done. All right. We are. Thank you very much. Have a wonderful day, and I hope you learned a lot. Take care now.